Good afternoon to one and all. Is it audible? Is it audible to all?
Yes, sir.
Okay, we'll start this session in few minutes. Is the presentation visible? Anyone can type. Yes, sir.
Sir,
Anyone can type in the chat box, or anyone can unmute your mic and say. Okay.
sir,
Then, shall we proceed for today's session? So, in the last class, we had seen 6 problems. So, the continuation of that we are going to see. Okay. Question and solutions. In the last class, we had determined the properties. We had proved the properties of mutual information. All the 3 properties we had solved it and proved each and every property, followed by solving 2 BSC problems, binary symmetric channel problems we had done. So in the next, we are going to see problems based on the same type of binary symmetric channel if matrix is given. Okay. In the previous problem, we had seen that only the binary symmetric channels, probability of occurrence of x1, x2, y1, y2 were given, which are your inputs and outputs respectively. From that, we had obtained a transition matrix. From that, we had determined h of y or h of y by x, probability of x is to y, and at last we had found mutual information. So that is a type of problem. So in the next type of problem that we are going to deal is that the transition matrix itself will be given. So the question states that a binary channel matrix with inputs x1, x2, outputs y1, y2, having the probabilities of occurrences with y1 over x1 is 2 by 3, which is this. I'll show you this one. And the probability of occurrence of y2 over x1 is 1 by 3. y1 over x2 1 by 10, y2 over x2 9 by 10. So this is your given binary channel matrix. From this given matrix, we should determine h of x by y, h of y by x, and mutual information. Okay. So the h of x is entropy of x. H of x by y is conditional probability of x over y, and h of y by x is conditional probability, conditional entropy of y over x. And at last we should find mutual information. So first of all, we'll make a note of the given probabilities or given channel matrix. We'll compare with the standard matrix. Okay, P is equal to P of y1 over x1, P y2 over x1, P y1 over x2, P x2 over y2 over x2 is equal to the given transition matrix as it is. So write as it is. So in this question, since the probabilities of sources of x1 and x2 is not given, we'll be assuming it as 1 by 3 and 2 by 3. So let us assume P of x1 is equal to 1 by 3 and P of x2 is equal to 2 by 3. So the data whichever is being given is being written. From the above matrix, we can easily find that since P of y1 x1 and P of y2 x2, P of y1 x1 is 2 by 3, P of y2 x2 is 9 by 10. So which is not same. Then according to our condition of transaction matrix, P of y1 over x1 should be equal to P of y2 over x2. If that is the case, we call it as binary symmetric, or else it is binary non-symmetric channel. So now you could have understood that this channel is a binary non-symmetric channel. Binary non-symmetric channel because P of y1 over x1 is not equal to P of y2 over x2. So this we should keep in mind that why this is called as binary non-symmetric channel. So for this, the same procedure is to be adopted for finding h of x. Entropy h of x is equal to P of x1 logarithmic to the base 2 1 divided by P of x1 plus P of x2 logarithmic base 2 1 divided by P of x2. So x1 is, as we had assumed, 1 by 3, substitute 1 by 3 log to the base 2, 1 divided by 1 by 3 will become 3, so it is 3 as here, plus P of x2, we had assumed it as 2 by 3, 2 by 3, so 2 by 3 log to the base 2, 3 by 2. So simplify using your calculator and check whether you're getting this bits per symbol, 0.9182 bits per symbol. Is this clear? Any doubts in this? Obtaining entropy h of x. Let me check in the chat box. Is there any queries? I think no queries still in the chat box. So I'll proceed for finding the next h of y. So determining h of y is as common as we had seen in the previous problem. First, we need to know the probabilities of x1, probabilities of x2, and the channel transition matrix. So I think probability of x1 and x2 is assumed 1 by 3 and 2 by 3. So write as it is. Then this channel transition matrix is being given in the equation. So substitute, then simplify. How do you simplify? Row versus column. So this first row versus the first column, first row versus the second column. Multiply them and you will get this value 0.2889, 0.7111. Check this, kindly check this. If anybody is able to operate or if anyone is having calculator, check these values. So from this we can get P of y1 0.2889 and P of y2 0.7111. Now from this you can calculate entropy of y. So entropy of y can be calculated as P of y1 log to the base 2 1 divided by P of y1 plus P of y2 log to the base 2 1 divided by P of y2. So P of y1 is this 0.2889 log to the base 2 1 divided by 0.2889 plus 0.7111 log to the base 2 1 divided by 0.7111. So simplify using your calculator. You can use your FX 991 or FX 350 ms or 100 ms, whatever it might be. All will have logarithmic functions. So use that and check whether you're getting 0.8672 bits per symbol. So till this h of y is over. So let us see what we have to calculate next. We have determined h of x, we have determined h of y. So next we need to determine h of x over y or h of y over x. For that, we need to determine the joint entrophies. Joint entrophies. So joint entrophies as we had done in the previous, in yesterday's class. P of x1 y1 is equal to P of y1 x1 over with respect to P of x1. P of x1 y2 is equal to P of y2 over x1 with respect to x1. So these are with respect to x1, these are with respect to x2. Okay, so we can easily calculate. P of y1 x1 is what we had seen. P of y1 x1 is you need to see the here it is. P of y1 x1 is 2 by 3. Write it. P of x1 we had assumed 1 by 3, so 1 by 3. So you get 2 by 3. P of y2 x1, y2 x1 is this, which is 1 by 3 again into 1 by 3 is 1 by 9. Next P of x2 y1, x2 y1 can be obtained by P of y1 over x2. Y1 x2 is this, which is 1 by 10 here into P of x2 we had assumed 2 by 3, so into 2 by 3, so you get 2 by 30. And P of x2 y2, which is P of y2 over x2 into P of x2. So here it should be 9 by 10. It is not 9 by 19, it is 9 by 10. Yeah, this is 9 by 10, not 19, 9 by 10 into 2 by 3. So you get 18 by 30. Let me check. Somebody has. Okay. Here I'll write the notes. 9 bar 10 into 9 bar 10 multiplied by 2 bar 3 is the correct answer. It's not 19, it is 10. Okay. Moving on to the next. Now, actual joint entropy that we are going to find. Okay. We have two symbols x1 and x2. So summation I is equal to 1 to n. It should be n. Again, another typing miss, typo error. Sorry for that. I is equal to 1 to n. J is equal to 1 to m. P of x of I, y of j, logarithmic to the base 2, 1 divided by P of xi, yj. So since we have two symbols, we will get four possibilities. So x1, y1, x1, y2, x2, y1, x2, y2. So we can write this joint entropy as P of x1, y1, logarithmic to the base 2, 1 divided by P of x1, y1, plus P of x1, y2, logarithmic to the base 2, 1 divided by P of x1, y2, plus P of x2, y1, logarithm base 2, 1 divided by P of x2, y1, plus P of x2, y2, logarithmic base 2, 1 divided by P of x2, y2. So substitute the equivalent values. On simplification, substitute these values, all these values correctly. You will be getting 2 by 9 log to the base 2, 9 by 2, plus that is 1 by 9. So 1 by 9 log the base to 9, plus here it is 2 by 30. 2 by 30 log the base to 30 by 2, plus next is 18 by 30. So 18 by 30 log to the base to 30 by 18. So using your calculator first, simplify logarithmic functions, then check whether you're getting this as your value. This 1.5365 bits per symbol is your value. Next is to find conditional entrophies, where we have h of x by y and h of y by x. So h of y by x can be obtained from the formula h of x comma y minus h of x. Already we had found h of x. Just now we had found h of x comma y. So minus that, we'll be getting this 0.6183 bits per symbol. Similarly, find h of x by y. H of x by y is h of x comma y minus h of y. Just now we had found h of x comma y 1.5365 minus this h of y. So h of y, let us recall how much we got. Yeah, h of y 0.8672. 0.8672. So simplify, you will get this. Check with your calculator. After this, we need to find the mutual information. So the mutual information is obtained as h of x minus h of x by y, or h of y minus h of y by x. So h of x is 0.9182 minus h of x by y is this 0.6692. Manipulate it. We'll get 0.249 bits per symbol. Similarly, for another relation, h of y minus h of y by x. So h of y is 0.8672 minus h of y by x, which is 0.6183. So you get 0.249 bits per symbol. So from this you can conclude that both the equations will be getting same results. And with this also we can conclude that h of x minus h of x over y is always equal to h of y minus h of y over x. This is a simple problem. So any doubts? Uh, yeah, how we wrote p of x of 1 and x of 2. It is an assumption in this problem.
Shall we take
We are
second row,
assuming
sir?
here. Yeah, we are assuming
Shall we take second row also,
the
sir? If only first row only we want to take, sir.
for which one, x1 or x2?
X2, sir. In four numbers, any number we want, any number we can take, sir.
Yes, let me show it. Yeah, you can take any number.
Okay, sir.
If you take any number and solve also, you'll get the
Same
values
only.
according to that. According to that.
Okay, sir.
And at last, this you'll get as same. Where
Okay,
this
sir.
mutual information, this two will become same. Mutual information from I of x over y with this formula and this formula will get the same answer. Same answer
Okay.
means not this 0.249. These two will be same. Okay, understood?
Okay, sir.
These two will be same. If this is 0.5, this will be 0.5. Okay. So that depends upon the value of x1 and x2 that you choose. This
Okay,
is for
sir.
an example or assumption. We are taking 1.3 and sorry 1 by 3 and 2 by 3. Since in the question it's not being given. Okay. If you take the least values, you'll be having good manipulation. You can manipulate it easily. If you take larger values, the manipulating will be a bit difficult for you. Okay. Any doubts? If you want, I'll and keep in mind that this is not a this channel is what is not an binary symmetric channel. I'll show you that in this slide, so you can go through for this one. This is not a binary symmetric channel. Why? Because this 2 by 3 and this 9 by 10, these two positions are not same. So I'll give you 2 or 3 minutes for going for such that you can go through over this for 2 or 3 minutes. Then we'll start the next problem. Any doubts in this question? Okay. So we'll go for another problem with the channel transition being given. Now, can anyone tell me whether this channel transition matrix is binary symmetric or not?
Okay.
Yes, anybody? The question I'll read out, then you can tell me. I'll ask one by one, don't worry. The channel transition matrix is given by always this side. The rows are your inputs, the columns are outputs. So 0.9, 0.1, 0.2, 0.8. They're saying us to draw the channel diagram, determine the probabilities associated with the outputs. Okay, assuming equiprobable inputs, and at last they are saying to find the mutual information. So now I think most of us all would have been familiar as how to find this mutual information, how to determine mutual information. Okay, so everyone make a note of this: 0.9, 0.1, 0.2, 0.8. Okay, I'll ask you one by one whether it is a symmetric channel or not. Okay, have you made a note? Though the symmetric is not being connected with this, it's not connected with this. Just it's for your information, or this is how to identify easily. So I'll ask one by one. I think everyone would have made a note of this. Hey, who is saying that it's not binary? Tanuja, it is binary only, not binary. You should say non-symmetric. Okay, got it. It is not binary. It is non-symmetric. I'll type it non-symmetric. Binary channel or not symmetric binary matrix. Non-symmetric. Okay. So who will answer this? Anybody is ready other than Vishnu, other than Tanuja? Anybody else is interested? Harshavardhan is there? Yeah, Harshavardhan. Let me ping on Harshavardhan. Harshavardhan, is he available? Harshavardhan? Yeah, Harshavardhan. He'll, his DP looks very smart, like him. Harshvardhan has to reply at this question.
Sir,
Ah, Harshvardhan, what is your lunch today?
today, right, sir?
Okay, had it.
No, sir. Eating now.
Uh, So it's on the way.
Yes, sir.
Okay, okay. So you had seen this question.
Yes, sir.
Okay, tell me whether it is. What could be the answer for that? Have you understood the question?
Yes, sir. Non-symmetric.
It's non-symmetric. How do you say? How do you say why it is non-symmetric? Don't say that Tanuja has said. Don't say that Vishnu has said. Don't say that I had typed. Answer is correct, but how? Okay, at the end of the class, you try to retrieve it. Have your lunch first. Okay, have your lunch. Okay. So again, I'll read out the question. Drawing the channel diagram, determine the probabilities associated with the outputs, assuming equiprobable inputs. Okay, then finding the mutual information. First, write the given data. So P of y1 over x1, y2 over x1, P of y1 over x2, P of y2 over x2, write as it is. 0. 0.9, 0. 0.1, 0. 0.2, 0. 0.8. Then they had said that inputs are equiprobable. Equiprobable in the sense, equiprobable means they are equally placed, or the probability of occurrence of each of the symbols is equal. The probability of occurrence of each inputs should be equal. So equiprobably, we can write P of x1 as 0.5, P of x2 as 0.5. Since we are having two outputs from the transition, we can make that, since two columns, two outputs will be there. Okay. So divided by 2 equiprobably, we'll get 0.5, 0.5. So now the challenge is how to draw the diagram. I think somebody had asked the same doubt in last week, how to draw this binary symmetric channel. At that time, if you would have listened, this would be very much easier. So since we are having inputs, two inputs, right, x1, x2, two outputs, y1, y2. P of y1 over x1 is the transition, y1 over x1 is 0.9, y2 over x1 is 0.1, y2 over x1 is 0.1. Next, y1 over x2 and y2 over x2, 0.2, 0.8 respectively. Y1 over x2, 0.2, and y2 over x2, 0.8. So this is how to draw the channel diagram. Is there anybody having doubts in channel diagram drawing? If you have doubts, ask now itself, or I'll draw it again for you. Your team has reached maximum number of votes for pre-plan. So how to draw? Let me. We are having two inputs. P of x1, P of x2. Outputs P of y1, P of y2. This is how to draw the channel diagram. Though my line might not be straight, always the direction should be from x to y. This color. So we are drawing the diagram for that. This is the arrow mark. So now P of y1 over x1, you have to see what it is. Y1 over x1 is 0.9. So we'll write 0.9. Similarly, for P of x2 over y2 is 0.8. Then P of x1, y2 over x1, y2 over x1 is 0.1. P of y1 over x2, y1 over x2 is 0.2. So this is how to draw binary symmetric. Sorry, not binary symmetric. This is how to draw the channel diagram. Let me save this. This is how to draw the channel diagram. all these symbols should be always 1. So our input combinations are 0. 0.5, 0. 0.5, which we call inputs x1, x2, x3, x4. This 0.2 each. Yeah, I think I was at the question of equiprobable. So probability maximum of occurrence is 1 divided by 4. So equally probable is 0.25, 0.25, 0.25 each. If it is 3, 0.333, 0.333, 0. So this is how we assume inputs. I addressed somebody's question. Yes? Sure. Okay. Thank you, Vishnu. We will proceed for the next. Okay. So drawing the channel diagram is over. So next, determining output symbol probabilities. So how do we find? As the same fashion as we have done in previous two problems. P of y1, P of y2, P of x1, x2, transition matrix. Write it as it is. Then substitute the equivalent values. Our x1 and x2 are zero point 0.5, zero point 0.5, x1 zero point 0.5, x2 zero point 0.5. So remaining the transition matrix as it is. So now multiply the row with columns. Row with columns. You'll get this answer. So the probabilities will become P of y1 as this, P of y2 as this. So make a note of this, P of y1 and P of y2. So which is 0.5 for this problem, 0.45 for y2 for this problem. Next, after finding the output symbol probabilities, we need to find mutual information. So mutual information we are done already. So this is your formula, P of x1 over y1. We need to find P of x2, P of y1, P of x1, P of y1, P of x2, y2. All these things will be found. Okay. So next term. This is how to find, as we wrote in previous two symbols. So mutual information will be summation I is equal to 1 to n, j is equal to 1 to m. So n is 2. Two. So you can expand that in inside also. So mutual information can be given by P of y1 over x1, P of x1 logarithmic to the base 2, P of y1 x1 divided by P of y1. P of y2 over x1, P of x1 logarithmic to the base 2, P of y2 over x1 divided by P of y2. Plus P of y2 over x2, P of x2 logarithmic to the base 2, P. I think there is some network issue. I think so. Or is this somebody is removing me from the meeting? I'm not sure. This is the second time today, so I have been moved out of the meeting. Why it is like this? Okay, I'm not sure how this is happening, but okay, I'll try present it again. I'm not sure where did my network got out. So can anyone tell me from which place should I explain it again? I'll show you the presentation. Yeah, can anyone unmute and tell me where I had left? From where should I continue?
ಶೆಡ್ಯೂಲಿಂಗ್ ಲೆಕ್ಕ ಕೊಡುತ್ತೆ ಅಷ್ಟು ಕೊಡ್ತಾರೆ ತಮಿಳು ರೀಡಿಂಗ್ ಪ್ರಾಕ್ಟೀಸ್ ಕೊಡ್ತಾರೆ
Last slide itself. Yeah, whether check this slide, whether this is the slide.
No, sir.
From this one, drawing the
Move forward, sir.
diagram, is that clear?
Yes, sir.
Next, this one.
Yes, sir.
Okay, this is okay from here, right? From I of x is to y.
Yes, sir.
Okay, right. Thank you. So, I of x is to y, our generalized formula for determining mutual information. I is equal to 1 to n, j is equal to 1 to m, p of yj over xi into p of xi log to the base 2 p of yj by xi divided by p of yj. So this is our basic mutual informations formula. Okay. So substitute two things. Since we are having two input symbols and two outputs. So simplify or substitute the values of each and everything and my symbol. And how do we write this is? This is same as you have done for the previous three problems. Same type of mutual information.
హలో క్లాస్ అయిపోయిందా? హలో
I'm not sure why I'm getting a network cut very often. Or is that somebody removing me from the meeting?
Sir, no one can remove you, sir.
But this is third time again
Sir,
I'm
you
getting
honor, sir.
third time I'm being getting moved out of the window.
Yes, sir, but you are the owner, sir.
Yeah,
Even
I know that. I'm.
yes, sir.
What could be the reason? Any idea?
నెట్వర్క్
I'm
ప్రాబ్లమ్
not
సార్.
sure.
Due to network problem, sir.
Network issue, sir. Getting some
Is
noise also from you, sir.
it happening for everyone?
Yes, sir.
No,
Sometimes it
Yes, sir.
happens
is
sir.
it happening for
While network is slow.
everyone or not only?
Yes, sir.
Not now, sir. When network is slow, it will happen, sir.
Okay, even for other subjects also it is occurring like that.
Yes, sir.
It's
Yes, sir.
occurring like that
Sometimes,
only, sir.
sometimes it happens. Sir.
Okay.
Sometimes it happens, sir.
Morning, anything like that?
Sir, some people can automatically be left from the meeting, sir, due to network issue.
Okay.
And some noise also getting, sir, from you.
Yeah. There
Sounds.
is some work is going on behind my house.
Okay, sir.
That I cannot avoid it. What to do? It is neighborhood. They are doing
Okay, no
some
problem.
construction work. Yeah. Yeah. If there is any uh, left off or if there is any network cut from my side, kindly WhatsApp me such that I can check it okay, or I can join it again. It's pinging. Okay, I'll go for presentation directly. So, are you all clear about question number 8? Is 8 clear? For the time being, I'll skip the question number 9 because this will take at least 45 minutes. for explaining question number 9. So this way I'll teach you, I'll tell you in the next class. Question number 9. Why I'm saying it will take 45 minutes is that the concept is same. The concept is same. Same things we are going to find. We are going to find h of x. We are going to find mutual information, and also the capacity we'll be finding. Okay, with given some probabilities of p of x1 and p of x2, p of x3, and also the transition matrix is given. So the major difference between the above or the previous problems that we had seen and this problem is that this is ternary channel. We have, see the matrix size 3 cross 3. So to make you understand that, it will take surely I'm sure that it will take 45 minutes or so. So which might not be equally sufficient in this. So I'll say about this question number 9 problems and solution in the next class. Don't worry. So meanwhile, I have another problem to be solved, which determines this. This is an relation where the extension of our Shannon's first theorem lies. Okay, so show that if there are m number of equally likely messages, then the entropy of the source is log to the base 2 m. So this is what the extension of Shannon's first theorem is. So this we are going to prove it. Okay, so how do we prove? Let us see. First, we know that m is the number of equally likely messages. Likely is that similar type of messages. And the probability of that is always 1 by m. Probability is always 1 by m. And if there are m messages, the probability will also vary from all those things. So p of 1, if there are so many probabilities of occurrences, p of 1, p of 2, p of 3, p of 4, p of 5, p of 6, p of 7 till p of m. For all those things, we will be having 1 by m only. Since our number of equally likely messages is m. Now what we are going to do is that we are going to simply substitute that in the required entropy. In entropy. So entropy formula is H is equal to summation k is equal to 1 to m pk log to the base 2 1 divided by pk. So we are having till m. So p1, p2, p3, p4, p5 till pm we can write. So p1 log to the base 2 1 divided by p1, p2 log to the base 2 1 divided by p2 plus p3 log to the base 2 1 divided by p3 till pm log to the base 2 1 divided by pm. Now simply substitute the equation of the probabilities 1.6.8 here. P1 is 1 by m, P2 1 by m, P3 1 by m, P4 1 by m, and even Pm is 1 by m. Now add Now you can see, I think so. Add all the m number of terms. Add all the m number of terms. So we will be getting in summation, entropy will be always equal to log to the base 2 of m. Yeah. So this is your except for question number 9 that you'll see next class. This presentation is over. So any doubts? Any doubts you can ask. You are with pleasure to ask any doubts in this yesterday's problems and today's problem. Question number 9 solution, we will do it in next class. Don't worry about that. In next session entirely we'll be dealing with M array channels or the ternary channel with m is equal to 3. Yes, sure. You can ask the question. What is your doubt? The question you can type or unmute your mic and ask. Yes, Tanuj, I can ask the question. You can type. Second step, you have split the probability. Right. Okay. Yes. Equiprobable condition. Condition is equiprobable. In that, which formula you have applied in that? Formula for finding equiprobable is that probability of occurrences of all the symbols is always 1. So that divided by the number of equiprobable symbols. All right. 1 divided by the probability of occurrence of all the symbols is 1. For example, if I have inputs as M, oh no, I'll write it as D. Okay. If I write it as D, the formula is 1 by D. And if D is equal to 2, if D is equal to 2, what will happen for each probability will be and in some cases if D is equal to 5, if D is equal to 5 means there are 5 input symbols in equally probable condition. Then what do we get? For each probability is equal to 1 by 5, it is 0. Now understood? Equiprobable is this. Yeah. Any other questions? Okay. Any other doubts or any other questions? Lakshman is there. Lakshman, I have a question for Lakshman. Rather than you ask, I have a. Lakshman, this Pavan Kalyan Reddy. Pavan Kalyan Reddy, yeah. Who
41, sir.
is he joining or coming for class? No, I think so.
Yeah, sir.
Yeah, but he is there in our WhatsApp
Coming
group.
for some classes, he is not coming for some classes.
Is he present in the WhatsApp group? Yes, sir.
I have to check, sir.
Okay,
I
kindly
have to
check
check,
it.
sir.
I had informed to your class in charge also regarding his non-attendance for the past 2 or 3 weeks. He is not attending class and his absence in Google Classroom also. I think Reddy Kumar of C section has joined in
Yes,
Google
sir.
Classroom. He has joined in Google Classroom, but he is yet to join this meeting. He is not there. In this meeting, he is not there, or in this class, he is not available. Thank you, Lakshman. Check over Pavan Kalyan. Pawan Kalyan Reddy.
Okay, sir.
Check it and let me know.
Okay,
You
sir.
can
Okay,
either
sir.
text me or WhatsApp me, no issues. Okay.
Okay, sir.
Okay. Thank you, Lakshman.
Okay, sir.
And
Thank
from
you, sir.
B section, Kishore is absent today, I think so. Kishore, Kishore is there? So I'm waiting for any other queries. Okay. Then shall I
No,
go for
sir.
attendance?
Sir.
Okay. Shrija? Shrija is there?
She's
Say
there, sir.
okay. Then she can leave the meeting then. Shrija can leave. I'll mark it for Shrija. And Srikala also can leave. I'll mark it.
Okay, sir.
Okay. Only two can leave, Srija and Srikala. Remaining wait, I'll check the attendance. K Vamsi, turn your mic and give your attendance. K Vamsi. I think K Vamsi is not there. Kishore is also not there. Manaswini. Manaswini is there? No. Surya, Chandana.
Yes, sir.
Yeah, you can leave the meeting.
Okay, sir.
Harshita.
Present, sir.
Yeah, you can leave the meeting. Pranit.
Yes, sir.
Yeah, you can leave the meeting. Pranit. Lakshman.
Thank
Yeah, you can leave the meeting. Pavan Kalyan is absent. Tanuja,
Yes, sir.
some doubts. Yeah, you can leave the meeting. Naresh Reddy,
Yes, sir.
you can leave the meeting. Pavan Chandra,
Present, sir.
you can leave the meeting. Sri Sai Srikar,
Present, sir.
you can leave the meeting. Venkat, Purna Venkat,
Present.
you can leave the meeting. Sri Vishnu,
Present, sir.
you can leave the meeting. Harshavardhan,
Present, sir.
you can leave the meeting. Sai Vamsi,
Absent, sir. Right.
Sai Vamsi absent.
Yes, sir.
Okay, thank you. Then remaining all attendance is being marked. You can leave the meeting. Thank you.
Okay, sir. Bye, sir.
Okay, thank you.
Bye, sir.
Okay.